Hello everyone, welcome to the day 5 of AlgoWeek. The topic for today is binary search. And first of all, uh, it's been a great week, and I'm happy to see 37 people on a Sunday evening. So that's a great thing. This will be the agenda for the day. We will be having the small recap of binary search algorithm. Next up, we will see one question, one lead code question we will solve. Then we will move to the main topic of today, that is binary search on answer. Uh, you guys can at least find 20 to 30 interview questions that are based on binary search on answer pattern. So we will learn this through an example. Then we will do one more question that will be on lead code, and as usual, at last we will be having the quiz. So this is me. I'm Meet. I'm the sublet at GDG DSA community. We have Arnav with us. He will be assisting us with. He will be assisting today with overall setup. These are our QR codes. You guys can scan and we can connect over there. So we have already on the day 4 we already covered the binary search, right? What is binary search? Binary search is a searching algorithm. Uh, in Let's say for this example, here we have an array, and the target given is 7. So we use binary. The one way to do is we go to each array manually, each element manually, and find the 7 that leads to big of n complexity. But how binary search helps is we have low pointer, we have high pointer, and we check and we discard whichever the part is not required to us. So here we take low pointer, we take mid pointer, and whatever the mid pointer is pointing to, we check every time the condition. Here, I won't be diving much into binary search. I hope you guys already know binary search, what binary search is. It is an algorithm or technique used to find the target element in a sorted array. Okay. We check the middle element, then decide to go left or right based on the comparison. We compare this mid element, and based on that comparison, we either discard this part or the right part. Binary search works on sorted data. As you can see, this it only works on the sorted data. Okay, so this was the recap of binary search, and the time complexity was big of log n. That I hope it was clear. So the question that we are going to solve is lead code 852. That is peak index in a mountain array. We are given an integer mountain array of length n, where the values increases to a peak element and then decreases. Return the index of the peak element, and they have given the hint as well. Your task is to solve it in log n time complexity. So let's understand what mountain array means. I think they've already given that mountain array is where the values increases to a peak element, that is value increases to a peak element and then decreases. So this is something how the mountain array looks like. The lead code example only we are taking. Here we have 0, then 1, and then 2. So as we can see, if I try to uh, draw the plot, suppose this is indexes, this is elements. So this represents 0, this is 1, and this will be 0. So this is something kind of a mountain structure, as we can see. Similar for the second example as well. 0, 2, 1, 0. So this is also a mountain array. What we have to return? We have to return the index. Whatever the index we find here, that we have to return as the index of the peak element. This is what they are saying. This is what the question says. Now our task is to find the index of the peak element. Let's understand mountain array if you have any doubt. Mountain array first strictly increases. So let's take the example that is on the right hand side, 0 to 5 6 till 9. every element to the left to 9 is strictly increasing, 0, 2, 5, 6. So what do they mean by strictly increasing? 0 to 2, sorry, 0 to 5, 6, they are strictly increasing. Why? Because uh, none of them are same. If it was 0 to 2, that doesn't mean it is strictly increasing. 0 to 5, 6 is strictly increasing. And similarly on the right hand side to the 9, 8, 5, 3, 2, 1, they are strictly decreasing. That means before the peak element, every next element is greater than the previous. Okay, this is kind of a hint to solve this problem. We'll go to the trackpad once again. Okay, let's say this was the array before the peak element. Here, what is the peak element? This is the peak element. And before the peak element, every next element is greater than the previous. Okay, so if I'm standing here, what represents the previous element? This is the previous element. So current element will always be greater than the previous element. This element and this element. This is the previous element and this is the current element. So current element will be always be greater than the previous element. Okay. Next, what does the mountain array means? Every next element is smaller than the previous one on the right hand side after the peak element. So after this was peak. After peak element, every element, this is the current element. Let's say this was the next element. Then this next element will be lesser. I mean lesser. That means the current element will be greater than the next element. Here this is current and this is next. So current will be greater than the next one. So how do we solve this? We can go to each element one by one. So this there is a word here, monotonicity. What does that represent? It's simply the monotonic nature of the graph, as we can see. Uh, Something like this. So this was the peak element. Before the peak element, every element was strictly increasing, and after that, it was strictly decreasing. So this and this, they both represent the monotonous nature, and that is what they are saying: monotonicity of the mountain array. So uh, arrays like this are called mountain arrays. And so yeah, we were solving it, right? We go to each element and we try to find, we just check whether that is the peak element or not. How, if I'm standing at 9, how do I know that this is the peak element? If I'm standing here, what I'll do, I'll check the previous element, this condition, and the next element, this condition. This condition, this should be lesser and the next element also should be lesser. That means peak should be greater than the both element. So the uh, final condition looks something like this. This is the current element. This, there is a previous element here. There is a next element here. It should be greater than the previous and also should be greater than the next element. This is the final condition to check. And let's also do the coding part as well for this approach. Okay, so what we are doing, we are going to each element and we are checking whether the both conditions are getting fulfilled. Okay, we will go to the editor. Okay, let's go to lead code itself. Okay, so we are given an array and we have to find the peak element. So what I'll do, uh, let me quickly take the n for the size of the array. what we are doing, we are iterating through all the elements, and there is a if condition. If that gets fulfilled, that means we found the uh, peak element. We will return the index. Here they are saying to return. So we will directly return the index. What was the condition? There is a current element. It should be greater than and greater than. It should be greater than the previous element. It should be greater than the next element. But this uh, doesn't work. So we'll put an end here. If both are correct, then we'll directly return. If not, then they have not said anything. So uh, we will assume that every time the peak element will occur. So there will be no conditions like this. Okay. So these both are not mountain array. Why? Because the increasing part is missing here, and here the decreasing part is missing. So nothing like this will happen. So here we will just return -1 for the safety. This will be error of I-1. This will be error of I+1 that represent next element. So before I run, can anyone find any bug here now? Or bug or any edge case that we are missing? You guys can quickly do the chat box. You can type if you can find, you can type it in the chat box. Will this code work or not? Yes or no? You guys can type. No one? Okay. So basically, if I start from 0, then I-1 will lead to out of bound. And similarly, if I'm standing at I is equals to n-1, and if I do I+1, it will try to access array of n. That will also be give the array index out of bound error. So we will only run for n-2. Sorry, n-1. So this was only for the edge case handling. All right, we'll try to submit it. And it got submitted. Can anyone quickly? Uh, oh yeah, IDX was not initialized. That I corrected. Can you guys give me what is the time complexity here of this algorithm? Okay, can you explain the loop once again? Okay. Uh, let's understand this through an example. We are taking the example number 3. I'm only putting all of them into the graph. 0, 10, 5, 2. So what we are doing is, this is our array, that is 0, 10, 5 and 2. I'm going to each each element and checking. So if I'm standing here, I'm checking whether this is my peak element or not. If yes, then I'm directly returning. I'm directly returning the index. So if I'm standing at 0 and this is my peak element, then I'll directly return, because I don't need to check further. But in this case, this is not the peak element. So I'll go to the next index. I'll come here. I'll check whether this is greater than the previous element. Is this greater than the next element? If yes, I will directly return. I will directly return the index that was 1. I directly return this index. So I've already found the peak element, so there is no need to go further. I hope this was clear. And if you're asking about the edge case, okay, if you're asking about this, Then I'll go here. This represent the zeroth index, right? Is this clear to you? Who asked the question? Sivam. I hope you are getting that this is the zeroth element. This was the zeroth element here. So if this is the zeroth element, then can this zeroth element be the peak element? We are clearly given in the question that mountain array, sorry, peak element is where the uh, like increasing thing happens and then it decreases. So this should be the peak element. In order to this be the peak element, there should be a element that is lesser than this on the left side and on the right side as well. Here, before the peak element, every next element is greater. So what I was trying to tell is this cannot be the peak element. And similarly, here there is no decreasing part. So this last element cannot be the peak element. So we can directly reduce both of them here. I'm not checking for 0, I'm directly checking for 1. And similarly, okay, if I do n minus 1, then I have to do n minus 2. I mean, it's just the, we are only checking till the second last index. I'm only checking till the, where was the graph? I'm only checking till this part. I'm not going to the last element because this element I know that it cannot be the peak element. So I'm doing that. And with that logic, it also handles the edge cases. This will not go the, this will not overflow the index out of bound. Okay, so Unnati got the answer, Ishan got the answer, Sanskriti got the answer. Unnati again changed the answer to login. Fine. So the, how do you find the time complexity of this? What we are doing, we are going to each element, right? From 1 to, wait, I'll write. From 1 to n minus 1. So what is the time complexity here? We are going to 1, from 1 to n minus 1. That is n minus 1, uh, n minus 1 time complexity. But as we you have already learned in the first session, we ignore the constants. So this will be the time complexity. For those of you who have changed the answer to log n, are we actually discarding any part here? Like for the brute force, what we have done, we are going to each element, right? We are going to each element. We are not discarding any part. So the time complexity is big of log n. And in order to optimize this, we have to discard some part. What I'm currently doing is I'm going to each element. Now, the important pattern to observe here is, just wait a second. So how do you optimize this solution, right? It currently it looks perfect, right? There, I cannot, like, clearly we cannot find out this can be further reduced, like there is one more efficient solution possible. But here they have already given the hint that it can be solved in the log n time complexity. And as soon as I see log n, I will only think of binary search. That's kind of a hack you guys can remember. Whenever you see the log n complexity, think of binary search. But let's not think about binary search directly. Let's observe the pattern here. Oh, I'm not able to draw. Okay. So let's say this is my uh, uh, mountain array, or this is what we are given, 5 6 something like this, 5 2. This is the given array. Okay, let's say I'm standing here. Okay, this is where my I is, or current pointer is, or anything, any variable you want to tell. I'm standing here and I'm checking whether this is the peak element or not. It is not, right? Because the next element will be is greater, whereas it should be lesser, right? So this is not the peak element. Let's go to the monotonicity, right? Before the peak element, every next element is greater. So every next element is greater. So is there any meaning if I'm standing here? Is there any meaning I go to this side? Will my peak element be here at any case? It is not possible, right? Because it is in an increasing order. So the only possibility is on the right side. If this is what the case is, like current element is lesser than the next element, so I can discard this part. Okay, this is clear. Now what if I'm standing here? This is where my current pointer is. If I'm standing here, then I will check with the next element whether my next element is greater or lesser. Here it is lesser. That means I am on the, okay, so current element is greater, right? Current element is greater than the next element. Current element is greater than the next element. uh, Current element is greater than the next element. That means I am on the decreasing part. If I'm on the decreasing part, then on the basis of monotonicity, I know that I have somewhere I've missed the peak element. If I'm on the right side, if I'm here, then I know that I have missed the peak element on the left side, and I can be very sure that the peak element will never be on the right side. So I can definitely discard this part as well. So that is what we are going to do for, that is how we are going to apply binary search. We will take two pointers, low and high. This you have to think and answer in the chat box. What will be the values of this? And I'm just writing the classic binary search template. We have this, we have a mid pointer, low plus high, high plus low minus, sorry, high minus low by 2. Then we have a mid condition here. Then we have a else if condition, and at last we have else condition. So I think this is clear, right? This is for mid check that we do. And why did I do high minus low? That was for integer overflow. I guess this was covered with in the day four session. Okay, Unnati is saying low is equals to 0 and high is equals to n minus 1. Any other answers? Okay, let me write the mid condition and then let's see if anyone can answer. So if mid is, I'm writing this part. I'm standing on the uh, left portion. For that, I'm writing this condition. I'm standing on mid and the previous element, and then is greater than, just a second. If I'm here, okay. Yeah, that's correct. And the mid is greater than the next element. Then we found the mid. We will directly return. What will return? Mid. Mid is index. Else if. Now, here from here, this is the discarding part in the binary search, right? From here onwards, we do discarding. Else if I'm on the left part, I'll discard this part. And if I'm standing on the decreasing part, I'll discard the right part. So how do you check that? If current mid is greater than the previous one, previous element. That means I'm on which part? Left part. Left part. I will discard this part. How do I describe? How I discard? Here is the low. So I'll take low to the current pointer. Current is mid. So I'll take low to the mid plus 1. Else, we have checked this condition, the left condition, we are only left with right condition. So I'll do and is first. Okay, so here we will have the high pointer. I'll take it to the mid minus 1. High is equals to mid minus 1. Here the same thing, we will return the mid. If something not happens, like this function is int type, so we have to return something. Okay, nobody has answered for low and high. as it was in the previous submission, it will be the same. Low will start from 1 and high will be pointing to the second last element. Second last element is n minus 2, right? So this will complete our whole code. Low is equals to 1. And let's submit it. So yeah, this was the binary search, and I hope you guys know the time complexity for binary search is log n. This was for brute force, and this is for optimal solution. If you have any doubt regarding this problem, you guys can ask in the comment, ask in the chat box. Otherwise, raise your hands. I hope this was clear. We have already included the solution as well. You guys can check it out. Okay. Can't we take highs goes to n minus 2 as we ignore the last element? We have already taken the highs goes to n minus 2 right here. High is already n minus 2. And the next question is why high is equals to n minus 2. Okay, what is the index of the last element? Let's say I have a okay, let's take this example. The size of this array is 1, 2, 3, 4. This is a 4 size array, right? Size of the array is 4. What will be the index of the first element? First element is first element's index is 0, right? And what is the index of the last element? Last element's index is n minus 1 because the indexing is 0 based. So 0, 1, 2, 3. 3 is the index for the last element. And why n minus 2? Because we are taking second last. So second last is what? N minus 2. That's why n minus 2. And why n minus 2, that I think I've already explained here. That the last element can never be the peak element. Similarly for first element. So here we are skipping this 0th element and the last element. We are skipping the 0th element here, and we are skipping the last element here. Instead of n minus 1, we are taking n minus 2. And because we are taking this, we are already fine with this condition. So what if the mid was 0? Somehow, while applying binary search, this mid turns out to be 0. So 0 minus 1 will lead to minus 1. That will be index out of bound. Similarly, if this was n minus 1, n minus 1 plus 1 is n. So here, for this example, is index 4 available? We don't have. That is index out of bound. So with this logic, that first element and last element can never be the peak element, we are already satisfying the out of bound errors. We are already fine with the out of bound errors. So yeah, any other doubts? Or next we will move on to the binary search and answers. You guys can quickly do +1 if it is clear and 0 if somebody has doubt. All right. Okay, so moving on to binary search and answers. So this is like a very important topic under binary search. So what is binary search and answers? It is nothing but applying binary search on answers. Like it's that simple. Applying binary search on answers. Let's understand this through with the basic binary search. In basic binary search, what we do is we have an array. We have to find the target. In short, we have to find the element from an array. But here we don't apply binary search on the array given. Instead, what we do is we apply binary search on answers. Okay. Okay. So let me ask you a quick question here. Okay, let's go to lead code. What was the search space here? Low was pointing to 1 and high was n minus 2. That was already in here, right? I mean, search space was the array. But in binary search, our search space will not be the array. Our search space will be answers. Whatever the answer possibles, we will apply binary search on the answer. Okay, it won't be clear, I'm pretty sure. Let's understand this through an example. The employee manager example. Just give me 1 second. Okay, I'll write the question here. How do I write? Insert text box. Okay, so the question goes like, let's take a hypothetical situation that we all got placed. Okay, and you have a manager that gives you tasks. Currently, you have a bag array. Let's say you have a bag that has 5 candies, 8 candies. Each element represents a different bag. So in the first bag, there are 5 candies, next 8, then 12, and last 15. So this is the bag that you have. Now, your manager tells you that there are k is equals to 2 employees. K is just a variable. Uh, this is what your manager has told you, that we have k is equals to 2 employees. And what's your task? Your task is to distribute bags so that employees, so that the employee carrying the max candies gets as less candy as possible. Okay, so your task is to distribute bags so that employee carrying the maximum candies gets as less as possible. Okay, so you started distributing the candies. Okay, you go to employee one, and start distributing the candies. You go to employee one and you gave him, let's say, uh, it's independent from this example. Okay, you gave him 14 candies. You went to employee 2 and gave him 15 candies. You went to 3 and you gave him 22 candies. To 4 you gave only 9 candies. So we have, what is the maximum candies that you gave to any employee? It is 22. The maximum number is 22. So our task is to minimize this 22. We have to minimize this 22. That is maximum candies that any employee is getting. Here it was getting 9, here it was getting 22, here 15, 14. But the maximum that one employee was able to get was 22. And our task is to minimize this. Okay, I think this is clear. Minimizing the candy part. And your boss now picks a random value. We don't know how he is picking, but I have noticed that. Just a second. Okay, the manager randomly picks values between 15 to 42. There might be some logic here, but currently we are assuming that he is picking randomly. Okay, so this was manager. And if there are more candies in a bag than that of allowed, okay, manager has put a limit. Manager has given you the limit that you can at max give, let's say, 29 candies. This is the limit range. Okay, this is the limit range. Your boss will only, your manager will only give the limit between this 42 to 15 to 42. Currently he has given, let's say, 29 as the limit, and your task is to distribute bags so that employee carrying the max candies gets the as less as possible. Now the condition here is, if there are more candies in a bag than that of allowed, that is, it is greater than 29, then give it to the next person. So how do you start allocating? Now this thing, your manager has already told you. Now it comes your task, how will you distribute the candies. So you go to, like, you start picking the bags. Let's say you took 5 candies from one bag, candies. Okay, and here one more thing is, you cannot pick candies from different bags. You cannot take 3 from second bag. You have to take 8. Otherwise, don't take it. You can take all 12. Otherwise, don't take it. So you go to bag one. You pick it. You go to bag two. You go to bag one. You go to bag two, and you pick both of them. How many candies do I have right now? I have 13 candies. Now we go to bag three and check whether this, if I also take the bag three, will I get out of this range, allowed range, that is limit. It is 25. So it is safe to take 3 bags at a time. If I try to take the last bag as well, that will be greater than 29. So this is not allowed. So what I'll do, I'll give this all these candies to employee one, because as I told earlier, if the limit is exceeding, we will take the new employee. So employee one got 25 candies, and that is under 29, so it is allowed. Now we have one more bag left, and our task is to complete all the bags. All the bags should be given to employees. So we'll take 15th, like the third, fourth bag, and we will give it to employee 2. Now we go to boss saying, yes, manager, I was able to give k is equals to 2 employees. If you set the limit to 29, I was able to give it to 2 employees, and that is what you told. So your boss will be, I mean, boss being boss, he will tell you, now do this task in now do this task in 22 as the limit. Now we has changed the limit to 22. Now the new limit is 22, and you don't have to think anything. You just pick bags as soon as you get out of, as soon as you get out of the limit, you just assign it to new employee. This I can go to employee 1. If I try to add 12, that will lead to 25, right? 18, 8 plus 5 is 13, 13 plus 12 is 25. So I cannot give 12, like 3 bags to employee 1. What I'll do, I'll go to 12. I'll pick 2 bags. I'll give it to employee 1. And then I'll pick third bag. I'll try to give it to employee 2 as max as possible, but this will also get 27. That is also not possible. So I'll do 12 to employee 2 and 15 to employee 3. Why I took third employee? Because this bag was remaining and I have to give it to, like, I have to finish all the bags. So if the capacity is exceeding, I will take new employee. So now this time you will go to the boss saying, I need 3 employees to, if you are setting the limit to 22. And this time, what is the maximum? It was 12, 15, and 25. What was the maximum? It was 25, right? Next time, so first time you gave it the positive response, right? Is that what you like observed? First case, when it was 29, you you told manager that I was able to do. Let's say that is true, right? You went with the positive response. Next time when the boss told you it was limit was 22, you went to him with false response, that I was not able to complete it in the 2. I need 3 employees for that. Next time your boss will say, do it in 25. Let's say whether we can do this or not. And you don't have to think anything. You just have to do the task, whatever the boss has given you or manager has told you to do. What you'll do, you will pick bag 1, you can pick bag 2, this will 13, this will be 13. You'll try to pick third bag as well, this will lead to 25. And what is the limit? It is 25, so we can pick third bag. What I'll do, if I try to add 15, that will be like exceed the limit, so I'll assign this to employee 1, and I'll assign last bag to employee 2. I think this is clear. So this time also you went to the boss with a positive response. Correct. That yes, I how many employees I took here? It was first employee here and the second employee here. So I went to a manager with positive response. Now boss again like tells you to do it in 24 second. Sorry, 24 as the limit. Uh, let's just see what happens here. We will be able to pick first two bags. If I pick 22, it will become 24, but our new limit is 24. So we will not pick this bag and we will assign this to employee 1. For 12 plus 15, I have picked third bag. If I'm trying to pick both, that will be 27. This is also not possible. So I'll give 12 to employee 2 and I'll give the last bag to employee 3. What was the maximum here? It was 25. 25, 15, 12. What is the maximum out of these three? It is 25. For 24 again, you went to manager with false response saying, I need 3 employees, but you told me to k is equals to 2. That is not possible. So you went with the false response. All right. Does anyone have any doubt here? Like, uh, why this is true, false, true, false, true, false? I think this is clear. It was 29 initially, then 22, then 25, and then 24 at last. Okay. So here, let me tell you that your boss was simply applying binary search. And the range for binary search was 15 to 42. Why this was the 15 to 42? Let's say if I start from 0 to 42, 42 is what? What is 42? 42 is nothing but the sum of all the array, sum of all the elements here. If you try to do the sum, you'll get 42. So your boss was simply applying binary search. He gave you 29 first. You told him that it was possible. He reduced the amount. He reduced the limit because he wants to give as less candy as possible greedily. So he reduced the limit. Now you went with false response. He again increased the limit, and the next time he again decreased the limit. So now answer will be this, like minimum candy possible is 25. Distributing minimum candies that max candy, like, so that the employee carrying the max candies gets as less candy as possible is 25. So the answer is 25 here. But how, like, here is why the boss was applying binary search here, but important thing here was we did research over here, right? This was the given array. We did not apply binary search here. Instead, what we did, we applied binary search on the answer. What were the answers? The sum of these two element can be the answer. Sum of all this array element can be the answer. Sum of this three, sum of this two. So what we did, we took a range that could be our possible answer. Our possible answer will always lie between this. For any other example, you just have to take the maximum element. Like for this example, for this particular example, you just have to take the maximum element and sum of the all elements, and that will be our search space. Search space, what do I mean by search space? Search space is from low to high. That is our search space. That is where we search, right? We did not apply binary search over here. Okay, let's go to this slide. Let me clean this off. Okay, this is fine. Search the range. We search through the range of possible answers. That is what we did, right? We took a range. We 15 to 42 was the range, and we apply binary search on this. We did not apply, manager was applying, and our task was this thing. We did not add any clue. We were just doing the task. We were the helper function, the check. Uh, in the binary search on answers template, we were just the check function. Our task was to verify whether this was whether the limit was possible for k is equals to 2 employee or not. So what we did, we reduced the like complex problem into simple yes no problem. Right, what we were doing, we were simply taking this, we were simulating all the array, we were going like 5 plus 8, 13, and we were simply coming to the boss saying yes or no questions. This is what our response was, and based on that, manager was doing binary search. So that is what the check function, and the search range was answers, not the given array. It was not, we were not applying here, it was the binary search on answers. And where was the monotonic property? Okay, to understand this, let's go to this slide. Some of you might have the doubt why it was 15, right? Okay, let's say if I take 12 and the bag array was, what was the bag array? It was 5 8 something. 5, why am I not able to write here? Just a second. Okay, 5 8 12 and 15. If the limit set by the manager is 12, will I be ever able to pick this bag? No, right? The answer is no. Why? Because the limit is 12. I can never pick this bag. However, at the same time, my task is to finish all the bags. If the limit is exceeding, I can take employee 3 instead of 2. But for employee 3 as well, the limit is 12. I cannot give 15. So minimum limit has to be the greatest element, right? If the limit is 5, if the limit is 12, then I would be able to this 3, I will be able to take this 3, I will be able to distribute this 3 candies, but this will never be possible, right? So the minimum limit will be the maximum element here, has to be maximum. And if I take okay, so the range I gave you was 12, 15 to 42. Let's say if I take very large range, let's say 70 as the limit. So what I'll do, I'll simply give all these candies to employee 1, right? I'll simply give all these candies to employee 1, and that will our task will be done. I will go to manager with the positive response. But the question says that it's very messy, I know, but just a second. Our task is to minimize the candy, right? So your boss will again tell you that 70, now you go to 35, now you go to 17, something like that. So this is the maximum, like this is the maximum possible limit that will be feasible for our searching. If you are going further than like more than 42, if I take 43, then what I'll do, I'll simply take all of this and assign it to employee 1, and this will solve. But again, you have to like iterate over, like there will be more iteration. And anyways, our task is to limit, so we will pick only during this range. What was 42? It was the sum of all these elements. So that is what this example was. And also the monotonicity I forgot. I think monotone is actually linked with this thing only. Okay, so let's start from 1 2 dash dash dash. This was the fifth element, right? So 5 8 just a second. 5 8, last element was 50. This was going till 42, and then if I try to go till 70 or any number, you can go to infinity as well. But okay, just to remember this thing, It was 29. 22 will be here, 24, 25, and 29. So for all these values, you will go to your manager with a false response saying, I cannot complete this for two employees. Right. For 22, you require three. For 24, you require three. That we already saw in the example while understanding. But as soon as I reach the limit as 25, every element after this were able to do in less than k. K is equals to 2 was the given, but if I pick 70, I can complete it in 2. So you will go to boss, yeah, you will go to your manager with the positive response. That is true. And all these responses are true. What should I return? I should return the minimum. Right, minimum was 25 in our case, so I'll return 25 is the answer. 25 is the minimum candy that an employee is carrying at max. So how do you identify the binary search on answer question? Just a second. Okay, we'll go here. This is again kind of a, like you can say, to how do you identify the that the question is about uh, binary search on answer. You find the monotonous nature, you somehow, like you observe your intuition or anything, you just get the monotonous nature and something like minimize the maximum or maximize the minimum. Maximize the minimum. Sometimes in the question itself they give minimize the maximum sum, minimize the maximum candy that an employee is getting. Whenever you see minimize the maximum or maximizing the minimum, you always go for binary search on answer. And this pattern will easily give you 20 to 30 question on lead code or any other platform. You guys can practice over there. It is the most questions that you will see will be categorized as medium and hard. But if you follow this template that I gave you right earlier, okay, I didn't give, wait, I forgot. Okay, let's go here. That's also fine. Why am I not able to type? Just a second. Okay, this is the template for binary search and answer. BSA template. Like using this template, you guys can easily solve 20 to 30 questions on this pattern. They all will be marked as medium and hard, but I think you guys can do it. So the first step is to define the search space. Like find the answer, what are the possible answers, and define the search space. That is low, you set the low, you set the high. If sometimes if you're not able to do exactly, just keep this in mind that we have to do low and high. And second step is you simply run the while loop. Third step is the check function. Whatever we were doing here manually, that we have to do it in code. Where was the slide? Okay, here. The check function. Just a second. There is a lag. Okay, so this is the check function. At last, what you do, you just reduce the search space. We will go to lead code and I'll try to give you the exact template that I'm talking about. This is the current template for binary search. I know it is already 7 p.m. We will just quickly wind this up. Then you guys can continue with the quiz. This is the normal template, right? This is the step one of the binary search and answers template. BSO template. All right. This is the first step. This is the second step to run the while loop. This is the second step. Third step is instead of this condition, instead of this whole condition, you have a check function. You can just define it like this, and you can write a check function over here. Before public, you just do int or void, whatever, based on whatever the condition is. In our case, it was int, right? So I'll do int check function, and here I will, okay, this could be int, this could be bool, this could be void or anything. Here we will have the condition. In our case, it was simulating the distribution. We were going to each, we were like gathering all the buckets of like bags of the candies, and we were seeing what I can take an employee count, right? Int employee is equals, initially there will be 0, and as soon as the limit, like if it is greater than limit, what I can do, employee plus plus, I need extra employee, and at last I'll do return whatever the employee count that we found, that should be less than or equals to k. So this will become boolean type. So what we did, okay, here we will have an answer as well. Under the first step itself, we want the answer at last, right? We are iterating over 1 to 42, like 15 to 42. At last we want 25 as our answer. So I'll define it as 0, and in this check function I'll pass k. K was the employee count that was given by manager, and current mid. This mid condition will be the same because we are only applying binary search. And as soon as this mid is valid, I'll consider this as an answer. Answer will become mid, and I'll try to find the lesser one because we had to do as less candies as possible. So what? How do you reduce the, like, discard the unnecessary part? You simply take high to mid minus 1. And in the else part, we will not have this else if condition here for binary search and answer. We will simply move low pointer to mid plus 1. This will become your binary search and answer template. Don't worry, if you guys want, we will share this in the material that we will share tomorrow. This will be your template for binary search and answer. This is not the exact function that you should write, but I guess you get the point. Okay, let's move on to the last question for today. That is, I mean, again, very simple question. We just have to find the square root of x. We will be given a non-negative integer. Okay, let's directly go to the lit code itself. Okay. How do I do this? I'll simply reset. Okay. Let's read the question first. We are given a non-negative integer x, and we have to return the square root. What is square root of 16? Square root of 16 is 4. I think you know this, right? And we are given that we have to return the integer. Okay, if it is non-negative, the answer will always be non-negative, so we don't have to worry about this. They have explicitly said that you must not use any built-in exponential functions. So you cannot use square root of x. Like in Java and in C++ and C, we have math.h library, right? We cannot do square root of x. If I do, it will definitely get submitted, but it is not the right way to do it. Like, I think it will be submitted, but that is not the right way to do it. They have already told it. You must not use it. Right, it will be submitted. We won't be using this as they've already told not to use it. So if they have not allowed to use this built-in functions, like built-in libraries or anything they have not allowed. And we have to round it down to the nearest integer. So square root of 16 is 4, right? But what is the square root of 17? 17 square root is 1.73, and it goes on. But here the answer should be 4. Nearest integer, we are just rounding it down to the nearest integer. All right. If I want to find the square root of 16, if I want to find the square root of 16, what I'll do? One way to do this is I'll run a for loop. I'll start from 1. I can start from 0 as well. I'll go till x. I'll increment every time. And I'll check if I into I. Like square root is basically square into square, right? If this is becoming x, and then I'll return I. So I'll go to 0. I'll go to 1. What for 0? 0 into 0. Is that equal to x? No, right? For 1, 1 into 1, is that equal to 16? No. For 2, 2 into 2, 4. Is that equals to 16? No. For 3, and when we reach 4, it will become 4 into 4 is equals to 16. So we'll directly return the index from here. So this was the, again, brute force approach, right? This will again lead to the big of x time complexity. Why big of x? We are running this for loop for 0 to x, 0 to x, till from 0 to x. So this, the time complexity will become big of x. How do you, again, as soon as I'm running this for loop in on answers, right? What are the possible answers here? Possible answers for a square root is 0 to x, right? Like, let's take one more example, like 81. For 81, our square root will, the answer will be 9, but like for 81, can the square root be greater than 81? Like, can it be 85, 87? It is not possible, right? And it cannot also be negative, like square root of any number is also positive. So our search space becomes 0 to 0 to x. This is our search space. And as soon as I get the search space, I'll directly, here we are getting it in big of n. Now further, to reduce the time complexity, the only possible way is sorting. Like, but here it is already sorted and sorting is already there, so I'll directly go to binary search, because currently we are taking big of n and binary search gives us log n time complexity. So like that we will be able to efficiently solve this question. As soon as I see binary search, I'll simply write the template quickly. While L is less than or equals to R, the thing to note here is I'm writing the binary search on answers template. Again, this is only for overflow condition. Otherwise, you can write high plus low by high minus low by 2 as well, high plus low by 2 as well. Here we will have the check function for mid. Else, what we'll do, we will simply reduce the search space or discard the search space. Here we will have the check function, and this is where everything will happen. For this thing, the check function is actually pretty simple. The check function will be again yes no question, so it will be boolean. Check function, what are all parameters that we need? We definitely need a mid and the x that we have to find. So we'll have mid here and we will have x here. What are we finding? Like what is the condition that we are checking? If mid into mid, is that equals to x? If this is true, then we are returning true. If this is false, then we are returning false. So I can directly return, like I can directly write a return over here. So whatever the answer that this will give, we will directly return it. Like, this is the same condition that we applied here. They both are same. Okay. if this is the thing, then I'll store the answer in, I'll store the mid in my answer, and I'll try to go like, I'll try to reduce the search space. What I'll do, I'll discard the right part. High will become mid minus 1. Else, the mid minus the check function return false, right? So we will come to the else block, and we will discard the right part, and we will sorry, left part, and we will point to left to the mid plus 1. And at last, what we'll do, return answer. Simple. Okay. So this low will be 0, as we have already seen the search space. High will be pointing to X. Answer can be empty in the initially it can be empty, because as soon as we found, we will return it. Okay, this will be high. If you have any doubt in this question, quickly drop them in the chat box. I'll see. Okay, Prem wants quiz. Okay. Sorry, by 2. So why is it failing? We are getting 0 as the output. It should be greater than equal to X. Oh, why greater than equals to X? Should be equals to. Okay, so if the check function is failing, all right, let's go to this. Just a second. Okay. If the check function is failing, then we have to do left is equals to mid plus 1. Sorry, if it is correct, then like this is equals to true. If this is mid into mid is lesser, then we have to increase, right? So left will point to mid plus 1, and high will point to mid minus 1, else in the else block. Again, there will be one more error here. Sorry, this is true. There will be one more error here. Just wait for some time. Do you guys think this will be submitted? We will get some error, and I want you guys to answer. Read this error and give if you have any solution, tell me. We got an error. The test cases were passed, but at last we got an error. So how do you solve this? And what if not? If you don't know how to solve this, tell me how, like why this error is happening. If anyone can answer. And we it is showing that we are getting the error over here for the line number 4. Okay, so we don't have time much, so I will not wait for that. So here what we are doing mid into mid, and the constraint says that the x can be 2 to the power 31. That is a very big number, and the variable that we have taken is integer. So the limit for integer is int max in C++, that is 2 to the power 31. And if I do 2 to the power 31, in the worst case, if I do 2 to the power 31 into 31, like into 2 to the power 31, this will exceed the integer limit, right? Integer limit is only this. And if I do mid into mid, then this will give integer overflow. And that is what we are getting here. It is saying integer overflow for this value. So what we have to do, we will simply use long here. I'm using LL is equals to long just for the sake of simplicity. This we don't need. I'll do long wherever we see long because we have to change it to LL. I mean long because we are getting integer overflow. and this will solve our error, and our code will be able to submit. So yeah, that was it, guys. We solved. I'll quickly give you the recap. uh, we had the recap of binary search. We solved one question, mountain array question. We had to find peak element. Then we moved to binary search. We understood this through an example, employee manager example. We had to give like, we had to minimize the maximum candies that an employee is getting. And at last we solved the very easy problem, square root of x. Again, uh, as an homework or anything, you can do, what if we don't have to return the nearest integer. Like I want to return, for square root of 17 for square root of 17 I want to return the exact value, like 4.713 point dash dash dash, whatever the actual value is that I want to print. How will you do that? I mean, this question won't accept it, but as a homework you can solve this. Square root of 17 should give exact value, not the nearest integer. So yeah, I think we can now move on to the quiz part if you guys don't have any doubts.